Hi, so today I will address a very specific type of question that is called the volume of revolution, which is basically an application of definite integrals. So if you have like any, like they'll give you, like how it works is that they'll give you a function, say f of x is equal to, I don't know, let's say x squared here. No, let's say x. F of x is equal to x because we want to keep it simple for this at the time being. And f of x is equal to x, and they'll give you an interval for 1 to 2 because like it's definite integrals. And now then there's a real bombshell. They'll say if you revolve the graph around the x-axis, then you have to find the volume. Yeah, if you revolve the graph around the x-axis, then you have to find the volume of the shape generated. And that's like really deep right there, right? It's pretty unconventional. So what this means is that you have your graph over here, and via the x-axis somewhere over here, you're from 1 to 2, let's say. So basically they're saying you take this section and you rotate it 360, and you rotate all of this 360 like this. Okay, you rotated 360, and the resulting object that's like, I don't know, like this. I'll try to draw it my best. No, it's sorry. Yep, it's like this. The resulting object, just ignore this part. Yeah, so the resulting object, you have to find the volume. And they will also give you the cross section, which is like how they revolve it. And in this case, it's a circle because you can see the cross section is a circle. At least what looks like a circle, hopefully. Sometimes they might even give you squares and stuff, but it's fine. We'll deal with that when they come. So how do you solve this? Like how do you generate a volume? Essentially, we take, so you know that the area of one of these circles is pi r squared, right? That's the area. So we, like with that in mind, we realize that if we add up the areas of all of these infinitely, then we get the volume. So summation of area is equal to volume. And you know what does the sum for us? The definite integral, our old friend. So all we have to do is that we act as if the y value is the radius, because it is the radius from the center, as you can see here. And you say that this radius, which is x, you do pi r squared because you want the area. So in this case, it's pi x squared. And you take this area and you do the integral of the area from 1 to 2 because you're adding up all the areas on that section to get the volume. And once you do that, you can get whatever you get, that is the volume. So as you can see, we just like plug it into the area formula and then do the definite integral of it, right? I hope I've illustrated that concept pretty clearly. But what if it's not a circle? What if it's a square? So if it was a square, then like if cross sections were a square, so if this became, I don't know how to draw squares, if this became like this or something, like a square at the cross sections, then what would happen is that instead of doing pi r squared, the area would now be r squared, right? Oh my god, I forgot the square formula. Would it be r squared? Yeah, it would be r squared because, dang it. Okay, yeah. No, it would not be r squared because you have this is the y value, but then it goes out like this and everything. So you really have 2r squared, right? I mean, like you have 2r whole squared. So area is equal to 2r whole squared in that case. If you like look at this from the forward instead of from the sideways. Yeah. So then you would apply that over here and do the same thing. So like that's how you sort of conduct these that's how you do these problems. And to quickly make this more clear, what a cross section is that like if you have this solid, and if I like my finger and I just like cut through my finger over here, like because my finger is round, like if I cut through my finger, then like if you look at this pencil, for example, if this pencil was like a big pencil, like if this pencil was like a big pencil and I cut right over here, then I would end up with a circular cross section because you can see it's circular here. So that's what I mean by cross sections, just as a clarification, because they will always ask for specific cross sections. Sorry for the long video and thanks for watching.